Hi there, Jake here. So I'm just going to explain to you how the Bunsen Air works. So basically there's two loops. One's just going to tap into the existing pipework. We're just going to take over that hot water. So it's going to come out of there through the Bunsen where it picks up a load of heat, and then it just goes back in and returns to your cylinder. So that's just a very simple water cycle, and it's just a small water pump that drives that around. So where does this heat come from that it's picking up while it's in the little heat pump unit? Again, that's pretty simple. Outside we're going to position two panels. They can be up to 10 metres away. They can go on a flat wall or a pitched wall or whatever. They can go in landscape or portrait, or if space is a problem you can just tuck one in behind the other. But we're going to put them where they're exposed to as much of the elements as possible. So wind's brilliant, rain's brilliant, obviously natural temperature, all of that stuff will help heat our refrigerant. Now what's a refrigerant? So the refrigerant is a gas that basically, or a liquid I should say, that boils at minus 26 degrees C. So all that happens is that refrigerant comes out, circulating through the panels and get exposed to all that energy from the wind, from the rain, and it will immediately change from a liquid into a bigger volume gas, which is why the return pipe is fatter, and that's why our exhaust pipe had two of them, not one, because it's now bigger and it's packed full of energy. And all that happens is when it gets back to the heat pump unit, the compressor will squash it back down to its original liquid form. Now, because it's been squashed, all that energy gets given off in tremendous amount of heat. What do we do with that energy? Well, we just run the water past it, and that takes the heat away. So the water is cooling it, everything is working better, the water's getting heated. It's an incredibly low efficiency running system. So here, this system's now running, so you can hear there is a slight noise to it. It's not silent, nothing's silent, but it's not prohibitive. This is the quietest unit on the market. So this system, when it's running, will use about half a kilowatt of energy. So for kilowatts, 13-14p, that means it's running is costing you about 6 to 7p an hour, depending on your electricity prices, so check them by all means. But we've done tests here at night, pitch black outside in November, heating this cylinder up here. We heated it from down at 28 degrees all the way up to 53 degrees, which is our target temperature. One test we did it in 2 hours, one test we did it in 2 hours 10 minutes. It's not an official test, but that's what it did. Pitch black in November, 7 degrees. So that gives you an indication of the kind of cost of running it. And all that happens is once it's reheated your water back to its existing target temperature, it just sits there, it does nothing. So they're actually in standby most of the time. Only when your water temperature drops, it'll bring it back up, then it'll go back to standby. That's the principle of how it works.